Okay, so we have the 2013 BC question number 6. So it is going to be a Taylor polynomial. So the first thing I would probably do is kind of recall this general formula, right? So we know that a polynomial of degree n, right, we have f of c, where c is where it is centered, plus the derivative at c, and that would be the linear term, and then the quadratic term comes from the second derivative at c, and then over that 2 factorial, and we know that that pattern kind of continues. So once you kind of realize that, then it says it's known here that f of 0 is 4, and we know that the first degree at a half equals -3, okay, and we also know that the first derivative at 0 equals 2. So basically, in this problem, so for here, right, so here in this problem, c equals 0, so we can do a little bit better. So we know that we're looking at something like f of 0 plus the derivative 0 x, right, and then plus the second derivative at 0 x squared over 2 factorial, and so on. Okay, so we need to kind of apply those givens, okay? We need to apply those givens into this. So we know that f of 0 is -4, right? So we've got kind of this piece here. And then we know that in total, right, that it has to equal -3, meaning the polynomial of first degree, meaning if you only had that linear term, okay, so if we kind of stopped it there, okay, then we know that that total equals 3. So I'm just going to say for part A, so we're going to say we're given, okay, 2 pieces of info. So we're given that f of 0 equals -4, and that the polynomial at 1/2 equals -3. So when we kind of put that into this general formula that we've got here, okay, we're going to say -4, there's that part, right? And then we'll say plus, we don't know this part, so the first derivative at 0 times 1/2 equals -3. We know that that whole thing equals -3. And so now we're basically solving for this first derivative at 0. We're solving for this piece here. So I need to add 4 to both sides. Okay, so if you add 4 to both sides, then you get the derivative 0 times 1/2, right, equals 1. And now I need to undo this 1/2 to get the derivative at 0 by itself, so multiply both sides by 2. So we have f of 0 equals 2. And I don't know, you could put a little check mark there. We did just verify that piece there. Okay. And I don't know how much that was worth. Let me check those scoring guides there. So that part was worth 2 points. Okay, so part A was worth 2 points there. And now we will take a look at part B. Part B says it is known that the second derivative at 0 is -2/3 and the third derivative at 0 is 1/3. Find the polynomial of degree 3 at x. Okay, so I'm going to kind of scooch this up here so we can see what's going on. So we've got part B for this one. So basically what we're going to do, since we know that the second derivative at 0 is, that'll be the kind of the coefficient on that x squared term up here. So I'm going to plop in that -2/3 right here. So we have something like -2/3 x squared over 2 factorial, and then it gives me info about this third derivative. So it's almost like I need to kind of continue this pattern out, right? So it would be plus, it'd be 1/3 x cubed over 3 factorial. So I maybe should have written out the next term there, but I was just kind of following that up. And find, so that would be almost there. I need to kind of combine with this with the other information though. So I would probably clean this up because I'm going to have to kind of combine it. I'm not really answering the full question yet, but I would say this divided by 2 factorial is just 2, so really that'd be something like -2 x squared over 6, which you could further reduce if you wanted, plus That's going to be, what is this going to be? That 3 and 3 from there. So I have x cubed plus x cubed over 18, because remember 3 factorial is 6, right? So 6 times 3 gives me the 18. So I've got that. All right, so that's kind of taking those givens. Now make sure you're answering the full question. So if we want a polynomial of degree 3 of x, we need to take the part that we know from part A, right? So we've got this part from part A, and then combine it with the second derivative and the third derivative information. So we've got -4 plus, and then when we plug that in, that'll be 2x, and then minus 1/3 x squared, then plus x cubed over 18 once I kind of clean it up with everything else, okay? And so this 2x, okay, if you're wondering where this 2 came from, right, we got that the first derivative at 0 was 2, so that just goes in right here. So we have the -4, and then the 2x. We got this part right here, and then the next term over here, and again, 3 factorial is 6, that's where that 18 came from, and we put it all in a nice polynomial for that. And that was actually worth 3 points, okay? You got a point for the first 2 terms, and then an additional point for the third, and then also an additional point for the 4th term there. All right, and then, so again, that was a point breakdown 2, 3, so that's 5, so that means that part C must be worth 4 points. And so for part C, what are we trying to do in part C here? The function has a first derivative of h prime, and then, oh, looks like it's going to be some sort of a chain rule here, I bet. It is known that h of 0 is 7. Find the third degree polynomial for h about x equals 0. Okay, let me get some room here. All right, so for part C, I'm going to have to replace the x's in the previous equation with a 2x, okay, because that's what we're doing in part C. So if we do that, okay, so we're going to replace, okay, the x's with 2x, right, because that's what's going on. If you look in this part, where did it go? Right, f of 2x. So wherever we see an x, we're going to replace it with a 2x. And that's replaced with 2x, okay? So that means that we're looking at something like -4, and then plus 2, and then wherever you see an x, I'm putting now a 2x, like that. And again, this is why it was probably worth it to clean it up in the previous step. Otherwise, you'll get pretty muddled in here. So I actually think it was probably worth it to simplify. And then 2x cubed. So we've got this. So we took that. Since I'm going to have to integrate this thing, okay, I would probably clean it up. And if you're saying, well, how do you know that you have to integrate it? Well, it's giving you the derivative, right? And now you're going to have to integrate. It's asking you for the original. So to go from the derivative to the integral, we're going to have to integrate. And so I would probably just do maybe a step of cleaning up before I integrate. So 4x. Be careful, this squared goes to the 2 and the x, so it becomes 4, so -4/3 x squared, okay? And then plus, this is going to be 8, so it's 8 over 18x cubed there. Okay, so yeah, you could reduce this if you wanted to 4/9 if that makes you feel better. But now we're going to integrate. So once we integrate this, okay, we'll have something like, right, tack on an x value. Okay, and so remember, when we're integrating this, the question for part C, if you recall, said that we wanted, we just want it to be a third degree polynomial in there. So be careful, we can stop a little early, because remember when we integrate, we're going to add 1 to the exponent, so this will be a third degree after we integrate this piece. So if we're kind of like integrating this, right, so we'll end up with -4x plus, right, add 1 to the exponent, divide by that number, so we get that's going to be squared, and then minus, add 1 to the exponent, divide by that number, so it's going to be 4/9 there, and then now we're a third degree, so now we can say plus c. Okay, so this is what we're working with, and now we're going to apply that initial condition. So remember your initial condition. So initial condition was that h of 0 equals 7. Well, if I plug in x equals 0, right, it has to equal 7. So that must mean that c must be 7, right, because I have 7 equals, right, so 7 equals 0 plus 0 minus 0 plus c. So in other words, c equals 7. Okay, so now that you've got that, my final answer, okay, my final answer to this, notice that I don't have an integer now, so this becomes my integer. So my final answer would be, okay, would be 7 minus 4x, and then plus 2x squared minus 4/9 x cubed. Okay, so that would be my Taylor polynomial, and that would be of degree 3. So you could call that, you know, Taylor of degree 3 of x equals that. Okay? And so that would be 2013 BC number 6, a Taylor polynomial.